Hello dear students, this is Mr. Muhammed Azeez. In this lesson we're going to continue on chapter 5 section 3 until the end of what's included for this academic year of Wuzari exam. This academic year is 2025-2026. Previously we stopped right on this example. Now we're going to solve this example using two different methods. The question is 2x bracket x squared plus 1 all squared. They can ask questions about this integral in two different ways, and we're going to solve both ways. Firstly, they can just ask for evaluating this integral, and if we want to evaluate this integral, we just do one thing. What is the derivative of inside? Derivative of inside is extremely important. Now, derivative of inside this bracket is 2x. Do I have 2x outside? Yes, I do. It's right here. So the part which is derivative of inside gets cancelled. Then the result is bracket power plus 1 over new power. X squared plus 1 is power 2. It will be power 3 over 3 plus c. If the question said evaluate this integral, this is how we evaluate. But this integral could be solved using substitution method. And if the question forces you to use the substitution method, the multiple choices will be in terms of u. Substitution method is going to be used on mainly three different questions. One of them is like this x multiplied by a bracket, or x multiplied by a radical, or if we have x and in the denominator there is a function that its derivative is like something like x multiplied by a number. Well, in these three cases we use integral by substitution, which is commonly known as u du. Now, what if the question forced us to use u du for this integral? Then always, what's inside the bracket, what's under the radical, what's in the denominator, these will be set as u. Now here for the case of this example, u is going to be x squared plus 1, only inside the bracket. Now if u is x squared plus 1, whenever you write u, immediately you write du. Du is going to be 2x, and as we said in the previous lesson, dx must be always included when you write du or dv. Here we just have u and du. Once I replace u and du into the integral, I should have like only u, du, and numbers. There should not be any x left over. If there is, it means the substitution is not right. Now, 2x dx, it's like here 2x dx. Du is covering both of them, 2x dx. Now, if I just write integral du, that means I already wrote 2x dx. Then, instead of this x squared plus 1, I can write u, and there's power 2 outside, that's power 2. This could be multiple choice. The integral could be given in the multiple choices in terms of u. This could be multiple choice. Or the result of this integral. Integral u squared du result is u power 3 over 3 plus c. This could be multiple choice as well. Or if they are not multiple choice, then where we put in place of u, we put the x squared plus 1 back, and we're going to get the exact same result as we wrote using the other method, not this one. The one we solved a few minutes ago. Replace the u with x squared plus 1. That's x squared plus 1 power 3 over 3 plus c. That's the same result as we evaluated the integral. Why we need to know this? Because this could be multiple choice. If you don't know how to do substitution, you might mess up the answer. Or this could be the multiple choice. So be careful. Do not ignore substitution method. Now this example, it's already solved, but I'm going to solve it in terms of u next to it. Now I have x radical. X radical is u du. We can solve it using u du. And we do it only if the question forced us, like multiple choices contain u. All right, now derivative of inside is 2x. It's available outside. This will get cancelled. Radical becomes power 1 over 2. Then the integral will be power plus 1 over the new power plus c. If I want to solve this in terms of u, firstly, what's inside the radical? I'm going to set this as u. U equal to, you can consider this method too. U is x squared minus 1. And remember, whenever you write u, you need to write du by taking derivative. Derivative of x squared is 2x dx. Now, instead of this radical, I can write it as a bracket power 1 over 2. So integral 2x bracket x squared minus 1 power 1 over 2 dx. Now replacing u and du, let's see. Integral u, as you know, it's covering 2x dx. So if I just write du is covering 2x dx, and u is like x squared minus 1. That's u, power 1 over 2. Now this could be multiple choice. And if we do the integral, it will be simply power plus 1 over new power. That's u power 3 over 2. And here 2 over 3 plus c. Replace the x squared minus 1 with u. We will get the same answer as here. So our target is not to get the final answer as this one, because there's already an easier method to do that. Our main focus is on these two steps, because if these become multiple choice, then you are forced to use substitution. This example, it's definite integration. Definite integration, the final answer is a number. Then we don't necessarily need to substitute using UDU. But there is one fact. If I say u is x squared plus 1, then du is going to be 2x dx. Here, I don't have 2x dx. Then I should add 2 here, 1 over 2 outside. Now, 2x dx together becomes du if we just do the substitution to it. And that's going to be radical u, which is u power 1 over 2. And 2x dx becomes du integral. The 1 over 2 outside is multiplication, stays. All right? One more thing can change. For definite integration, we don't write the upper limit and lower limit of the integral until we do the integral using u du. Final answer, put the x's back in place of u, then bring back the lower limit and upper limit. But what if the integral in terms of u has lower limit and upper limit in the multiple choices? What do we do? Here, we calculate the value of u based on the value of x. Now, if x is 2, what is the value of u? Put 2 here, 2 squared 4 plus 1 5. Then u is going to be 5. So if the integral in terms of x has the upper limit 2, then that same integral in terms of u will have the upper limit 5. When do we do this? Only if the multiple choices are in this form. Like the multiple choice is an integral in terms of u, and it has upper limit and lower limit. This has a very weak chance to come back. And when x is 1, that's the lower limit, the value of u, put 1 here in place of x, 1 squared is 1 plus 1, it will be 2. So this integral in terms of u, the upper limit and lower limit will be like this, from 2 to 5. Again, this has a very tiny little bit of chance to come back this way, but if you know, it's better. And then the rest, the solving is quite simple. Here we have 4 exercises. These 4 exercises simply are all the 4 cases of using UDV, integration by part. There is ln, there is x sine, there is xe, there is x cosine. Let's take them to the notebook and solve them. The answers are available. Here it's a matching question. The question itself says match, which you can easily guess which one belongs to which, but let's solve it. This has all the cases of using integration by parts. Then let's do it. Number 1, ln x. Integral ln x, in the previous lesson we studied, it's a rule. It's directly going to be x ln x minus x plus c. If they bring the negative to the front, It won't change anything. Negative x. This x ln x is positive, so I can write plus x ln x plus c. Now you might wonder why this x went to the other side and it's still negative. This x did not go to the other side. If x goes to the other side, it means it should go to the other side of equal sign, which it did not. It is still on the side. So when I change it, like when I switch it with x ln x, the sign will not change. But if I have like the calculation equal to a number, let's say, then when I send negative x to the other side of equal sign, then it becomes positive, which we don't need to do at all. B, x sine x. X sine x, I'm going to use tabular method. U is x, and dv is sine x. This dv we should do integral, and this u we should do derivative. Remember, this already has d. We should not do derivative on derivative. We should do integral. And here it is u. We should do derivative, then we get du. Okay, derivative of x is 1. Derivative of 1 is 0. Once you reach 0, stop. Plus, minus, plus. And if we have more terms, minus, it's by turn. Integral of sine is negative cosine. Integral of negative cosine is negative sine. Now multiply diagonally. Result of this integral, part b, is going to be negative x cosine x. Minus will be plus sine x plus. In Wazari, usually they bring the term with a negative sign, not in the beginning. They write it in the middle or at the end. And in the matchings, it's written like sine x minus x cosine x, which is fine. Now, let's do part C. Part C, we have integral x squared ex dx. Now let's use tabular method for this integral. Obviously, u is going to be x squared. Du is ex. For tabular method, we don't even write dx. That's making it easier. Now, derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 2 is 0. Integral of ex is ex. Integral again. Integral until we reach the 0. Now plus, minus, plus, minus. Multiply diagonally. We will have 3 terms. The result of this integral is going to be like x squared ex minus 2x ex. Positive 2 times ex will be plus 2ex, and there's always plus c. This is the integral of part C. Now part D. Part D is x squared cosine x. We're going to use the same idea using the tabular method. U is x squared. dv is cosine x. Now, derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 2 is 0. Cosine x integral is sine x. Integral of sine x is negative cosine x. And integral of negative cosine x is negative sine x. Now multiply diagonally. And don't forget plus, minus, plus, minus. Multiplying, we get the result of this integral. X squared sine x. Minus will be plus 2x cosine x. And finally, minus 2 sine x. And there's always plus c. This is the result of the integral of part D. Let's go back to the book. Here we have 4 exercises that are only asking about u and dv. Do not evaluate. Let's just follow the question. If I have x ex, then definitely the x will be u, and what's remaining, e power 2x dx is dv. When we have ln, we're forced to use u as the ln part. Only dx is remaining for dv. For this fraction, 1 over cosine squared is familiar. Its integral going to be tan. Then x alone is u. 1 over cosine squared is dv. Only in the case of ln, we don't set x as u. Now we have x squared cosine x. The part of x squared is going to be u, and dv is cosine x. Now questions 9 and 10. Questions 9 and 10 is like a function is given with its derivative. Just identify them. Which one is the function gx? Which one is the derivative of inside? Only this much. Here, inside the bracket is gx, 5x squared plus 1. That's gx. Derivative of 5x squared plus 1 is 10x, which is outside, then that's g prime. For question 9, we can find f as well. That's like composition of two functions. If I put this g into this function, I will get like bracket 5x squared plus 1 all power 2. But for question 10, it's a bit difficult to find f, and it's not required. The question itself did not ask for f. Now, inside the radical is going to be g x squared plus 1. Derivative of x squared plus 1 is 2x. I don't have 2x outside, then I have to make it. How? I write 2 here, 1 over 2 outside. Now, I can work on the question. I can identify g and g prime. G is x squared plus 1. G prime is 2x. That's it. Now this question 11, is a very good question. The bracket will be u and ex will be dv. X squared minus 1 integral x squared minus 1 ex dx. Now, how can I evaluate this integral? Since I have a bracket multiplied by ex, that's obviously u dv. I'm going to use tabular method. U is the bracket, x squared minus 1. And dv is e power x. As you know, for tabular method, we don't use dx. Now, derivative of x squared minus 1 is 2x. Derivative of 2x is 2. Derivative of 2 is 0. Stop. Integral of e power x is e power x. Integral of e power x again, that's e power x. And here, ex again. Don't forget, plus minus, plus minus. Multiply diagonally. The answer will be x squared minus 1 ex minus 2x ex, and finally plus 2ex. And there is always plus c. This is the answer of question 11. This question is purely UDU. If we don't use UDU, we cannot solve the question. Let's write it in the notebook and solve it. Integral x square root x minus 1 dx. We said there are 3 cases when we can use integration by substitution. And in the 3 cases I mentioned, x times bracket, x times radical, x times like x in a fraction, where the derivative of the denominator is containing x. Here, if the powers of x inside the radical or the bracket and outside are the same, then in this case, there is no way to do the integral, only substitution. And the substitution is always like this. U is what's inside the bracket or what's inside the radical. Whenever we write u, we need to write du as well. Du is equal to 1 dx, which is just dx. Now, if I replace x minus 1 with u and dx with du, I have an extra x. There should not be any x after I replace u and du back into the integral. Then what we do, there is a very smart trick. This x, next to it, I'm going to write minus 1 plus 1. So rewrite the integral. Next to the x, I write x minus 1 plus 1. Put it in a bracket. This minus 1 plus 1, it means we did not add anything to the function. I wrote minus 1, and to keep the balance right next to it, I wrote plus 1, which is fine. Multiply by square root x minus 1. And it's better to write the square root in terms of power. It will be x minus 1 power 1 over 2 dx. Now the part x minus 1 is equal to u. So here's x minus 1. This will be u. Here's x minus 1. This will be u as well. Now see, after substitution, it looks like this. Integral x minus 1 becomes u. The plus 1 stays. If a number stayed after substituting u and du, it's fine. So I should see only u, du, and numbers. Nothing else. No x, no dx. Multiply by x minus 1 is going to be u power 1 over 2 dx. We already solved questions like this in section 1. Now I multiply u power 1 over 2 by inside the bracket. Because the bracket is power 1, I'm allowed to multiply u power 1 over 2 by inside, and let's see what we get. We'll get integral. This x is already power 1. When I multiply it with x power 1 over 2, I will get not x, I mean u power 1 over 2. Multiply by u power 1, I will get u power 3 over 2, which is add the powers in multiplication. U power 1 multiplied by u power 1 over 2. Add the powers. 1 plus 1 over 2 is 3 over 2. Plus u power 1 over 2 times 1 is just u power 1 over 2 du. Now integral. Integral is quite simple. Power plus 1 over new power. No more integral sign. U 5 over 2 is the result of 3 over 2 plus 1. Or you have a calculator. It's a very good gadget. You write 3 over 2 plus 1. And you can easily see 5 over 2. If you didn't see 5 over 2, just press ABC under Shift. You will see 5 over 2 for sure. U power 5 over 2, and here 2 over 5, plus u power 1 over 2. 1 over 2 plus 1 is going to be 3 over 2, and here 2 over 3, plus c. This is the integral in terms of u, but if we want to evaluate it completely, we replace every u with x minus 1. That's going to be 2 x minus 1 power 5 over 2 over 5 plus u x minus 1 power 3 over 2 over 3 plus c. We can also write these in radical form. If you write in your calculator 5 over 2, we already had this idea in differentiation. If you write 5 over 2 in your calculator, you will get 2, 1, 2. The first 2 is going to be x power 2, and the 1 over 2 is going to be radical x. So here I can write 2 x minus 1 power 2 square root x minus 1 all over 5. This is how we open this power. Plus 3 over 2, if you write it in calculator, it's going to be 112. 3 over 2 is 1.5, and 1.5 is like this one, and 0.5 is written in the form of fraction, 1 over 2. The first one is going to be x power 1, and the 1 over 2 is going to be radical x. Together, it's going to be 2 x minus 1 power 1, and here radical x minus 1 all over 3, and there's always plus c. This is the final answer in the simplest form. This could be multiple choice, or the result in terms of u could be multiple choice, or the integral in terms of u could be multiple choice. Now see the whole solution. Yeah. Let's keep going. X cosine x, we already solved this. It's not new. Question 15 in this list is a good question. Each of 16 and 17 derivative of inside is kind of available outside. And these are easy stuff. Question 15. Question 15, fx equal to x cosine x over 2, and a point is given, and probably you know why this point is given. It's given to help us find the value of c. The question says, find antiderivative of f. Antiderivative, as a little knowledge, is f capital. Result of integral is represented as capital letters, and especially if this is f. If this is f prime, we would not write f capital. It's not a big deal, but if you know, it's better than not knowing why sometimes we write capital letters, why sometimes we write small letters. Now let's solve this. I'm going to use tabular method, of course. Integral x cosine x over 2 dx. Derivative of inside is 1 over 2. I have an extra x. Or you can simply see x times cosine is udv, and udv is best using tabular method. I set x as u, and definitely dv is going to be cosine x over 2. Derivative of x is 1. Derivative of 1 is 0. Plus, minus, plus. So far, everything seems normal. But whenever you see the angle in the dv part is not just x, we cannot do this integral. Only after a very good practice you can do it. Directly within the first glance, you cannot do it. Then what we do, just write the integral on a side. Integral cosine x over 2 dx. Derivative of inside is 1 over 2. I write here 1 over 2. If I don't have derivative of inside, I cannot do the integral. Since I wrote 1 over 2 here, I should write 2 outside to keep the balance. Now, derivative of inside gets cancelled, and integral of cosine is sine 2. The 2 outside stays. Cosine becomes sine. Angle never changes. This is the result. So dv, if we do integral, we will get 2 sine x over 2. If we want to do the integral of 2 sine x over 2, again, it is ideal if we write it as an integral 2 sine x over 2 dx. Again, I can send this to out because it's not derivative of inside, and I need to write 1 over 2 here. Derivative of inside is 1 over 2, and there is already, like, I have to write 2 outside to keep the balance, and there's already another 2. 2 will be 4 together. Result is 4. The derivative of inside gets cancelled. Sine, the integral of sine will be negative cosine. Right here, negative 4 cosine x over 2. Now multiply diagonally. X times 2 sine x over 2 is going to be 2x sine x over 2. Minus minus will be plus 4 cosine x over 2, and there is always plus c. This one, derivative of inside is 8x. How can I make 2x 8x? If I multiply it by 4 from inside and 1 over 4 outside. When we multiply by 4, we will get 8x. Derivative gets cancelled. Bracket power plus 1 over new power, and the 1 over 4 outside stays. Same idea for question 17. You can see the solution. And finally, whenever you see a point given, we use this point to find the value of c. And let's complete what we have started already here. The point, I'm going to put 0 in place of x and set the result equal to 3. Find c. This will be 2 times 0 sine 0 over 2 plus 4 cosine 0 over 2 plus c equal to 3. This 3 is the result, and x is the input. In place of every x, I wrote 0. This side is completely 0. It's gone. 0 divided by 2 is just 0. Cosine 0 is 1. Cosine 0, 1 times 4 will be 4. Then 4 plus c equal to 3. Send 4 to the other side. C equal to negative 1. After I find the value of c, the result of the integral, everything stays the same except instead of plus c, I write minus 1. then this is F capital, the antiderivative. There you go. At the end, there is written minus 1. It's the answer of question 17. Easy. X times cosine x squared times e power x. We already solved questions like this. Only at the end, once you input 1, once you input 0, until once you input pi over 2, once you input 0. These are easy. Same thing for question 20. Now finding the area of the shaded region.